Hi, this is Randall Schwartz, host of FLOSS Weekly. This week, Simon Phipps joins me. We're going to be talking about Linkerd, a way to get service discovery and all sorts of other cool things for containers. You're not going to want to miss this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for FLOSS Weekly is provided by CacheFly at CACHEFLY.com.
This is FLOSS Weekly with Randall Schwartz and Simon Phipps. Episode 463, recorded December 13th, 2017. Linkerd. This episode of FLOSS Weekly is brought to you by Rocket Mortgage by Quicken Loans. Home plays a big role in your life. That's why Quicken Loans created Rocket Mortgage. It lets you apply simply and understand the entire mortgage process fully, so you can be confident that you're getting the right mortgage for you. Get started at rocketmortgage.com/floss. It's time for FLOSS Weekly, the show about free, libre, open source software. I am your host, Randall Schwartz, Merlin at Stonish.com, bringing you each week the movers, the shakers, the big projects, the little projects, projects you may be using every day, totally unaware of it, projects you might want to download right after the show and play with. This show's a little bit specialized today, so maybe not so much, but it's going to be fun talking about it anyway. Joining me once again, my lovely and talented co-host, Simon Phipps. Simon, welcome back to the show.
Thank you so much. It's a pleasure to be here once again from a dark, cold, wet United Kingdom. I gather that you're down sunning yourself in Mexico again.
Yes. I'm actually down at my friend's apartment in Tijuana. I'll wave in Guillermo's general direction. He's not on this show this week, but he's often right over there in the playa. And this is more in the residential area. So my friend has had an apartment here for 4 years now. And it's all decorated. We call it the kitchen set because you see this refrigerator behind me if you're looking at this video. And it's got lots and lots of refrigerator magnets on it. But the show is not about us or our location. The show is about the projects we bring from the open source community today, no exception to that. We're going to have actually talking not about just one project, but two projects, Linkerd and Conduit. We're going to have come on in a few minutes, George Miranda, who knows a lot about both of those, and came on or has invited himself to be on the show to talk about these things. Just to give sort of a technical overview of what I think this is about. So, for the last few years, the big word has been containerization and building up things with Kubernetes and a bunch of other technologies in the area, Mesos, things like that. So we've gone from being like dedicated machines to being virtual machines to being orchestration with things like Kubernetes and containerization. And one of the problems that comes up when you have containerization is you're rolling out dynamic instances of various services, and they have to find each other somehow. I mean, if you can't talk to, like, from the database to the web server, then the web server is useless, the database is useless. So there has to be these orchestration systems. And apparently, from what I understand from only having spent like 45 minutes reviewing materials before the show, as I often do, is that Linkerd is one of the premier services in the area, the premier technologies in the area to do this sort of orchestration and service discovery, failover when services go away, best routing. It's apparently a proxy that runs at layer 5, which means it is aware of HTTP requests, things like that, and so on. Simon, can you add anything to that? I mean, that's a pretty technical explanation, but maybe you've got something you can come at us with.
Not really. It's a front end for microservices in where the backends are deployed in the cloud, and it works through some magic that I await to have explained to me by our esteemed guest.
Well, we can definitely have George come on in a minute and explain this a lot better. But before we do that, I have a very important message, because this episode of FLOSS Weekly is brought to you by Rocket Mortgage by Quicken Loans. The mortgage experience wasn't keeping up with the times. It was dated, and it needed a client-focused technological revolution. That's why Quicken Loans created Rocket Mortgage. Rocket Mortgage gives you the confidence you need when it comes to buying a home or refinancing your existing home loan. It's simple, allowing you to fully understand all the details and be confident you're getting the right mortgage for you. It's convenient. Their trusted partners allow you to share your financial information with Rocket Mortgage at the touch of a button. It's powerful. Whether you're looking to buy your first home or your 10th, Rocket Mortgage is able to perform thousands of calculations in seconds. Based on your income, assets, and credit. Rocket Mortgage can analyze all the home loan options for which you qualify and find the one that's just right for you. Rocket Mortgage by Quicken Loans. Apply simply, understand fully, mortgage confidently. To get started, go to rocketmortgage.com/floss. That's rocketmortgage.com/FLOSS. It's an equal housing lender, licensed in all 50 states, NMLS-ConsumerAccess.org number 3030. And we thank Rocket Mortgage by Quicken Loans for their support of Floss Weekly. Now let's go ahead and bring on our guest, George Miranda. George, welcome to the show.
Hi, it's good to be here. Thanks for having me on.
And where are you speaking to us from?
I am speaking to you today from Portland, Oregon, which is the anti-Mexico at the moment. It is very not maybe the way it sounds, just it's really cold and wet and rainy and the things you would expect Portland to be in the winter. I wish I was where you are.
Yes. Well, I'm glad I'm not quite where you are because, yes, I do live there, and actually I'll be there next week again. So I'm waving in your general direction, but I am waving to you from a sunny 76 degrees here, and I know it's cold and wet because I left that only a couple weeks ago, so I know how wet and ugly that can be. So 30,000-foot view, what is the problem that Linkerd is solving?
The 30,000-foot view, right? I think there are some things that you touched on that are very much true. But here's the problem, right? As folks have started to decompose into microservices, they've discovered that there's a fundamental building block that's missing. So I'll do a little bit of history here. Like I have an operations background, spent a lot of time in the video game industry, spent a lot of time in finance, did a lot of large-scale system administration. And in my day, and man, maybe I'm dating myself, but maybe not, it wasn't that long ago, you would have a traditional like 3-tier architecture, for example, right? My web server talks to my app server, talks to my database server. And you have a lot of monitoring tools at the layer 3 and layer 4 level, right? If there's a network transmission error, I'm going to find it. If I can't connect to one of those services, I'm going to know it. And then I can sort of triage what happened by looking at the event logs for the services that I'm concerned about, or maybe even doing a TCP dump between the two and seeing what's falling over, where is it going sideways. And it's pretty easy to reason about because it's like the service calls that are happening are relatively infrequent, or at least I know where they're coming from and where they're going to. But when you take that monolith and you decompose it into hundreds of different microservices, the relationship between those services isn't always clear, and you don't always understand where those requests are coming from and going to. And so the level of, I guess, darkness or invisibility that we've had around that layer 5 portion of the stack that you were talking about earlier, we've lived with it because it wasn't really a problem. But when you start doing microservices, you realize that not having visibility into that part of the stack really is a hindrance, right? And so here's my go-to example. As a developer or as a platform operator, if I am making a call to a particular service, let's say I make a call to my user service, that user service might be calling 6 or 7 other services behind the scenes to generate a user profile for me, for example. And if I make a call to the user service and it fails, all I see is, oh, the user service failed for some reason, right? But maybe behind the scenes, there was an authentication service or a logging service, and that's what's actually failing, and that's where the problem is. But as a platform operator or as a developer, I wouldn't know that because all I have access to is the direct service call that I'm making. So without visibility into knowing what were all the components that actually had to service this request that I made, without visibility into what those response codes were, without the ability to retry it, right, all I get is this thing failed and I don't know why. And so when people really start doing microservices the right way, I think something you talked about was containerization. And I think early on what we saw is a lot of taking monolithic applications and putting them into a container, right? But when you actually start decomposing that into microservices, that has a way of sprawling to be more than any one developer or platform operator can easily put their arms around. So you have a layer of invisibility that needs to be addressed somehow. And really, I think the core value of the service mesh is that it gives you a way to look in there, figure out what's happening, and make that service communication a lot more resilient.
So I can actually address this directly because of the ideas that I have. My primary client right now is ZipRecruiter. And one of the things we've been doing is moving away from this monolithic application model into being able to create microservices. And one of the problems we've had is tracing a request end to end. So like at the front end, we're adding an artificial token so that we can look at it in the various logs that are all being gathered together and trace it that way. Are you saying Linkerd solves some of this somehow?
Linkerd can help, right? And so the way that Linkerd is implemented, the way that most service meshes are implemented is as a series of interconnected proxies, right? Okay. And those proxies intercept traffic from your various processes, right? And just send it through this proxy layer that can supply a lot of rich data about what's happening, that has a lot of hooks and integrations. Linkerd supports open tracing projects. And so if you are going down the open tracing route, right, where you write in a particular header into all of your requests, because it's all happening at the proxy layer, Linkerd can track where these requests are and hand it back to your open tracing engine, like Zipkin, for example, right, which can reassemble the trace span and let you know, okay, when you made this request, right, it hit these 7 or 8 services, here's how long it took, here's what each of them did, and you can very easily, from one point, see what all of those relationships are and what was involved in processing this traffic.
How did Linkerd get started?
Well, Linkerd got started basically through experiences at Twitter. A lot of our core engineers are from Twitter, and there they developed a library called Finagle, which is also open and available. And so the idea was, if you look at some graphics from the time, Twitter started doing microservices really before the era of Docker. They started to decompose the platform into so many different services just to meet a lot of the scaling needs, right? And a lot of where Linkerd comes from are the days of the fail whale, right? Because Twitter had to figure out how to scale their services, they started to break them apart into these more manageable bits and distribute the platform. But when they did that, they realized that that layer of invisibility at the layer 5 part of the stack was really getting in their way. So they wrote a lot of custom libraries, and Finagle is a library that is meant to be included with your application that does things like handle service discovery, that does things like handle custom routing of traffic, or that does circuit breaking, or that does retries of network logic, right? And so a lot of this network control was very tightly coupled to your application when you used Finagle. And the problem was, so Finagle is built with Scala, right, which requires a JVM. And if you then had a polyglot service that had any other language, you had to rewrite that same application, a library, to include it. And then when you introduced another different language into your stack, you had to rewrite it again and again and again. And what we started to see was that pattern of having very tightly coupled network logic with your application didn't make a lot of sense, right? We should be able to decouple those two things and maybe push that network logic down into the infrastructure stack where you can manage it globally across all of your applications and maybe put less of that burden on your developers.
And so these various libraries then had to be written in the native languages then. How did you choose Scala to write Finagle and then Linkerd in?
Well, so the Scala choice was a choice made at Twitter, right? But when we founded Buoyant, the company behind Linkerd, we took a lot of that work. We took the Finagle library and we pulled it down into the infrastructure layer. And so Linkerd was born as a way to operationalize and productionize that focused experience into a more generic infrastructure product where this proxy layer was now transparent to all of your applications, right? As an application developer, what it meant is whether I'm writing in Scala or Ruby, right, or PHP, help you, right? You can now go ahead and proxy requests by just making a simple HTTP call, for example. And whenever that call went out over the wire, it would be intercepted with Linkerd, which had all this functionality built into it, and then it would be responsible for the things that you used to have to code into your application.
Right. So it's all very fascinating, George. It all sounds big hitting stuff. And I noticed that I've been looking at your company. You work for a company called Buoyant, and you've been given a lot of money by a lot of very big VC firms. So how come this is all open source? What is your model behind all of this clever?
Well, right now, both Linkerd and the new product that we just announced, Conduit, are open source. We're part of the CNCF, the Cloud Native Compute Foundation. And really, I think the Cloud Native Compute Foundation has been about finding the patterns that make sense in a microservice world that's running on top of unreliable infrastructure and providing you tools to be able to solve some of the inherent challenges effectively. And I think our involvement with the CNCF has been great. Open tracing, for example, is another CNCF project. And there are new patterns that come with that shift in technology. There's new tooling. There are new best practices that are starting to emerge. And I think for us, the choice to work open source and invite community contributions has meant that we've seen folks apply the service mesh in ways that we never thought possible. But getting to your answer around the business model, right now, everything that we do is open source. We're completely just focused on adoption and making sure we understand those problems well. I think if you look at the things that we're doing in 2018, you'll start to see the commercial strategy emerge. But fundamentally, we're committed to making sure that the tooling, like having that mesh layer available that makes service-to-service communication resilient, that will continue to be open and will always be open.
So this is Sun's old business model: adoption at zero cost, and you'll make profit on volume. Is that right?
Sort of. So I used to work at Chef Software before this. I've been in open source for a while. And though it's too early to talk about what happened at Buoyant, I think the model will be somewhat similar to what we saw at Chef, which is Chef being a config management framework is completely open source. And the commercial model there is there are some services and support, but the real value is some last mile tooling that helps take some of those raw building blocks that we give you and presents them in a polished, easy to use, easy to customize, and consumable way, right? That's what we did at Chef. And that's, I think, a good model for open source software companies overall. So you could probably expect to see something like that from Buoyant. But again, that's something we'll be focusing on later in 2018.
Right. Well, I really do want to carry on, drilling down on that, because one of the things that characterizes open source projects is understanding a little bit about the motivations for the originator. Makes you feel safe to participate. So looking at that, it sounds like you're going to go for the monetizing complexity model like CloudBees, rather than an open core model like, for example, Sugar CRM used to be before they decided to be closed core as well as closed service, as well as open core. Would that characterize it, that you're going to, it takes a lot of know-how to put your stuff together and you're going to monetize ameliorating that complexity? Or would you say you're going to be heading into an open source or an open core sort of a world where the code that's available at CNCF needs something proprietary that your company is going to provide?
Yeah, I'd say it's more the open core model, right? I've never been a fan of enterprise features, for example, or things that are withheld that are necessary to make the product work as a monetization scheme. And so I think when you do see a commercial strategy from Buoyant, it will be a completely separate product. It will be unrelated to what is in Linkerd and what's in Conduit. I mean, it will build on top of those things, but you should be able to implement the tool. You should be able to solve your own problems. And if you look at some of the things that we've done with Conduit, it's very simple. A lot of the complexity is removed. So I don't think it's even going to be monetizing on complexity, right? It's going to be monetizing on additional value that we can build on top of that type of existing solution. Right.
So you're involved in CNCF. I've been looking at your commit history here a little bit. How broad and diverse would you say the community around Linkerd is at the moment? Is it all your people, or is there a good number of people coming in from outside to work on the code as well?
We've had a lot of contributors, actually. In fact, the release that we did December 1st was almost entirely all community driven. There's been a lot of uptake and response to Linkerd. And so, yes, a lot of it is driven by engineers at Buoyant, but our community is thriving. And I I think the move to have a lot of components written in Scala was perhaps limiting to open source contributions. But if you look at some of the things that we're doing with Conduit, I think there have been some interesting choices that are made there, such as having a data plane that's written in Rust, a pluggable control plane that's written in Go. And I think that's going to open a lot more doors in terms of community contributions, although we're seeing that thrive with Linkerd as well.
Right. Yeah, that's a lot of very modern language buzzwords there. They're all after my time, as you might say. So how are you managing this? Are you just using a Git contribution model where you cherry pick pull requests, or do you have more of a governance than that around Linkerd?
There is some governance, and we're trying to follow a model very similar to CNCF. And if you look at our GitHub repo, there's a code of conduct that explains what the rules of engagement are around the community. I think Buoyant has been a very small, scrappy startup for a majority of its history. I just joined a few months ago, and one of the things that I'm doing at the company is spearheading the direction of community. And I think it's on my shoulders in 2018 to make that governance model a lot clearer, to make the rules of engagement a lot clearer. Right now, what we have is a model where you interact directly on GitHub. There's a very active Linkerd Slack channel. There's also a discourse forum for issues and concerns. And right now, it's all been very organic. But as we start to grow, I think it's going to be very important to define exactly what that framework is, right? Exactly what that governance model is. And I think you'll be seeing us address a lot of those challenges in 2018.
So you have other people on your team that have been making contributions that actually work technically, not technically for Buoyant, they actually work for Buoyant. That's not technically, they just don't do. Are you all based in Portland?
No, the company is actually based in San Francisco. We are a remote-friendly company, and maybe you know this, from your time in the community. I do a lot of field events. I do a lot of community events. And so I'm on the road a lot. It really doesn't matter where I am. However,
Sure.
We also have other engineers here, Hawaii, New York, California, distributed around the country. So we're a remote-friendly company.
Okay, so the primary thing we came to talk about today was Linkerd, but I noticed a lot of your material now refers to Conduit. How is that different from Linkerd? Is it Linkerd version 2, or does it have a different target?
That's a really good question. So Linkerd, I'll give you a little bit of history here. Linkerd was written in a very host-specific world. Mm-hmm. And so think about it as really hitting the market around the time that DCOS popularized a lot of patterns. And so Linkerd, because it's written in Scala, because it uses the Finagle library, needs things like a JVM. Right. And with Linkerd, if you give it a lot of CPU and a lot of resources, Linkerd scales up really well. And it will do, 10,000 requests per instance per second. And it gets incredible amounts of throughput and performance when you give it the right resources. So it's really good at scaling up, but it's not so great at scaling down. And we've been supporting users in production with the service mesh for about the last 18 months. And if you look at a lot of the functionality that we inherited from Finagle, if you look at a lot of what Linkerd does on paper, it does a lot of very powerful things like per request routing. It gives you ways to do not just canary deployments, but to, for example, funnel network traffic directly to your laptop to do production testing and send that back out to real production services that don't really impact what's happening in production. It gives you lots of built-ins to do things like retries. It has built-in integrations for service discovery. Has a lot of big, heavyweight, powerful features. But what we found from 18 months of supporting users in production was a little bit of an 80-20 rule. Right? There's 20% of the product that's really giving you the best bang for your buck, and a lot of features that, while they may conceptually and academically sound great on paper, aren't what people really want in a service mesh. And what we've discovered is people want the service mesh to be small. They want it to be lightweight. They want it to be blazingly fast, right? You want to not even notice that it's there. And when I say lightweight, I don't just mean from a resource perspective, being incredibly small and difficult to even, detect from a performance standpoint. I also mean conceptually lightweight. And so because I have an operations background, I think I tend to think of things this way. When my services fall over, when something goes wrong, I want to be able to reason about what's happening in the system. And I think in monolithic architectures, that's very clear. When we move into the cloud, for example, right, and infrastructure as a service with lots of different SaaS offerings, that gets a little more obfuscated. And when we start moving into microservices, even more so, right? And in this world of increasing complexity, where now we have a container orchestration platform that itself has lots of moving pieces and parts and, complex architecture to reason your way through, the service mesh should not be adding to that burden, right? It should be simplifying that world, not adding more operational complexity, right? So you really want that to be small and lightweight and simple. And so that's what we've done with Conduit, right? Rather than having a large heavyweight solution with lots of moving pieces that helps you tackle all sorts of complexity, Conduit is optimized for being small, fast, lightweight, easy to understand, and easy to get started with, right? And it has very few moving pieces, so it can give you the value that you get out of the service mesh, right? Which is just visibility into those requests, right? Giving you a pretty dashboard that lets you know what's happening, where the errors are occurring, what those error rates are, and some powerful built-in tools that let you reach into that proxy layer and extract the data that you're looking for. Think of it as like a TCP dump specifically at the layer 5 portion of the stack to help you with troubleshooting service-to-service communication.
So does this work alongside like Kubernetes? And so if so, where's the source of truth for things like failover and auto-scaling? Where does that live? Does that live in Kubernetes? Does it live in Linkerd? And how does it all work together?
Yeah, that's a great question, right? And so with Linkerd is a multi-platform solution that is meant to live on top of whatever infrastructure layer you've decided to implement, right? Whether that's TCOS, or whether you're using deployment schemes like Consul, right? Or whether you're using Kubernetes. And because of that, I think, again, it has some heavier weight components that just disregard what's happening in your infrastructure. And even in Linkerd, you'll see that, yes, there is a little bit of crossover in terms of who can handle service discovery and how. And I think that's what adds some operational complexity. So I think where we are in today's world is if you're a multi-platform shop, right, or if you're using anything other than Kubernetes right now, a solution like Linkerd makes sense for you, and the fact that it's living on top of your infrastructure makes sense. What we've done with Conduit is part of the way that we've minimized that operational burden is instead of building on top of Kubernetes, we have built it into Kubernetes. So it extends the Kubernetes API, and it also relies on Kubernetes built-ins to do things like, in the future, it'll do things like, look at the Kubernetes authorization model so that we don't have to reinvent all of those controls, right? You've already specified which services can talk to which other services. We should just leverage that, right? Kubernetes has built-in service discovery. We should just leverage that, right? Kubernetes has mechanisms for doing things like rolling deployments. We should just leverage that, and we should reduce the scope of what the service mesh is doing, to specifically speak to that platform. So it's two different use cases that we're going for there.
And that means that you have to provide different sets of complementary services depending on what your back-end layer looks like, right?
For Linkerd, that's true, yes. And the thing that is great and where Linkerd really shines is that it gives you a lot of different choices for what those integration points are. It supports a lot of different tools that we have found are used in that container orchestration layer. And so there you really have a possibility of mixing and matching, whereas Conduit is laser focused on Kubernetes right now.
And actually you touched on this a moment ago, but you start talking about authorization and security and things. And I'm wondering, so if Linkerd is acting as a proxy, clearly passing data from one end to the other to any one of the back-end service providers, what do you have in place? Does Linkerd have any native security layering or control so that it can keep from passing data that doesn't belong?
There are a lot of different options for doing that inside of Linkerd, and one of the things that I mentioned earlier is there's per request routing. It's a custom DSL. It's a construct that we call delegation tables, or DTabs for short. And you can use DTabs to explicitly state what routing of traffic should look like. And so you can get very fine grained with determining which sources should be able to route traffic to which other sources and where specifically that traffic is routed. You can use that to shut down communication, and you can use that in all sorts of ways, right? But you have to build it yourself. As opposed to something like Kubernetes, right? Where like in Kubernetes, what you do is, just leverage the model that they're using.
Cool.
So I've been digging around in GitHub while you've been chatting with Randall there. I had a bit of trouble finding the source code to Conduit because there doesn't seem to be a link on the homepage. Is that intentional, or is that just an oversight?
I think that was an oversight when we rolled out. If you look at the Twitter profile, a link is there. GitHub.org/run-conduit.
Yep. Well, that was
project.
That was the one I pinned down. So that is the right source. This is good. Okay. So looking at that on the front page, you suggest that it's not ready for production yet. Is that the case, or is that somebody not updating the about on the GitHub?
Yeah, so we just released Conduit last week at KubeCon and Cloud Native Con, put on by the CNCF. And we released it so folks could get their hands on it. So it is not production ready yet. And in fact, of your available service mesh options, Linkerd is the only production grade service mesh available today. I think there's been a lot of excitement in this space, and you see a lot of folks working towards that. What we are doing with Conduit, for those that are curious, is we are taking the existing feature set that is in this release and maybe the next release, and working very diligently over the next couple of months. Sometime in Q1, we hope, you should see Conduit ready for production use. Once it is stabilized, once we've gotten a lot of different hands on it, once we've accounted for testing a lot of different use cases and know that those are solid, we'll get it to a production ready place before we start adding new features to it. So That's currently the case now, but it hopefully won't be the case soon.
It looks like you have a small elite community there. I'm just looking. There appear to be 5 committers on there. So are you going to seek to grow that from CNCF contributors, or are you going to try and stay more focused on this as a company offering?
Well, I mean, being the initial release, right, being completely under wraps until last week, it was built entirely by engineers at Buoyant. But we are trying to structure that to appeal to the broader community. I think there was a lot of really positive uptake to that at KubeCon last week. So I think you should expect to see that contributor community grow within the next few months.
Right. And do you think that you're going to need both projects, or is Linkerd now going to kind of become the forgotten redhead child of the family?
Well, it's definitely not the forgotten child, but I think it'll be an interesting road. Right. I think where we're at is not yet. So Linkerd isn't going anywhere. We're going to continue to support Linkerd for the foreseeable future, and we want Linkerd users in production to be very happy with the offering. I personally believe that Conduit is built on all of the lessons that we have learned from using Linkerd, and I think what you can expect to see is that a lot of maybe call it creativity points. For new features, for new directions, will likely be spent on Conduit. And those two products will continue to live side by side. Maybe at some point in the future, if Conduit is so amazing and it has the type of support that our community needs and there is a clear migration path, then maybe you might see a merging of the products. But the current strategy is to maintain both of them and make sure that both communities are happy with the offering.
Right. And are you going to do all of this on GitHub? Are you doing bug tracking there? And I'm just looking at the numbers here, and obviously they're skinny because you've only just launched. But is this going to be a completely public project with a collaborative design from the community, or do you think for this time around you'll hold the roadmap more closely within Buoyant?
No, I think this is going to be a very collaborative process. And one of the things, in fact, that's on my plate is setting up a lot of proper onboarding. I think, as you mentioned earlier, right, there are some very new modern languages there. I think the Kubernetes community is very familiar programming in Go. I think Rust is a new offering or a newer language that has a little bit of a learning curve for folks to on-ramp to. And so I think what we want to do is set some expectations around what is happening where. For contributors, if you're curious, the Rust components of Conduit are all in the data plane, which should remain very unchanged, which, except for adding very specific features, hopefully should be very minimal and should not require a lot of modification. Where a lot of modification will occur is Conduit has a pluggable control plane written in Go right now through gRPC plugins. And so we expect that a lot of the community that is used to making contributions in Go will be able to make contributions here. But you're right, if you look at the GitHub repo right now, right, we just launched last week on Tuesday. It's very minimal. And so there's going to be a very concerted effort to grow that, to set expectations and let you know exactly how to plug in. Right now, it's all on GitHub. And the biggest piece of advice I can give you is, if you're interested, join the Linkerd Slack channel, linkerd.slack.com, channel Conduit. Let us know what you think, and we'll talk to you directly about how to get involved.
Right. And so I'm looking at all of those things. I see that the license you use for both projects is the Apache license. A lot of people who use the Apache license seek copyright assignment when they accept pull requests. Do you require a copyright assignment from external contributors too?
That's a really good question. I'd have to get back to you on that. I'm not sure that we have. I don't entirely know. I'd have to look.
Right. Because that's a critical question for anyone who wants to join a community. It's often the case that projects want you to assign copyright, particularly if they're VC funded, so they can accumulate IP for their future pivot. So I think that's a very important question, certainly for the people who tune in to hear me grill guests. You might want to find out for me.
Yeah, absolutely. And there should be a very clear contributor licensing agreement. I think there is, but I don't want to assume there is and give you an incorrect answer. So, but if you have questions, reach out to me directly, anybody that's listening to this podcast, and I will get you an answer and let you know exactly what to expect.
Okay, that's all fascinating stuff. So why did you pick the Apache license? Is that coming in from CNCF, or was there a specific reason why you picked it?
So I don't know the specifics of exactly why it was picked, but I do know that CNCF does have very precise rules that they want you to follow in terms of how you make your project available. They're very focused on protecting projects from having too much corporate interest expressed in the project. And so they have very clear rules of engagement around where and how we can have a corporate presence, how attributions should occur. And I don't know exactly if that's something that came from the CNCF. That would be my first guess. But again, right, still somewhat new at Buoyant, so I can get you a more precise answer with some follow-up. Maybe we can put that in the show notes.
Sure. Whatever you want in the show notes, just let me know. We'll make sure it gets on the website. So we actually had a question from the chat room. Borg, not his real name, I'm sure, asks, is there a list of what services the service mesh supports? Boy, that's a tough word to say. Can you talk a little bit about the layer 5 routing in Linkerd and what sort of protocols it actually understands?
Yeah, so Linkerd supports a number of protocols. There's everything from all TCP requests through an add-on called Linkerd TCP. So you can do everything from, like regular HTTP requests to like a database connection, for example. However, there are specialized protocols that Linkerd will interact with to understand what response codes are, like HTTP, right, in H2, gRPC is supported in Conduit. And so when you have specialized RPC protocols, there's a little bit more intelligence there, and we can understand what a response code is and whether it's something that can be retried or, whether it's, a request that isn't idempotent. Did it work? What were the error conditions, right? And we have a little more intelligence there. Right now, I guess to be very clear about that, Conduit in 0.1 only supports gRPC. And right now, Linkerd basically supports any request that you want.
Can Linkerd do things like session affinity?
Talk to me a little bit more, like what specifically are you asking about with session affinity?
Well, typically with session affinity, if you have a proxying router, if you get stuff from the same external IP address, you send it to the same backend with the theory that you have more hot data already related to that particular session.
Yes and no, right? So we will proxy it to a finite endpoint, right? And we can always direct traffic to this particular proxy endpoint. However, it gets a little strange because sometimes what you'll find at that endpoint are, multiple containers, like multiple processes, right? Like depends on how you've deployed it, like where that affinity ends. But at the proxy endpoint layer, yes, there is that affinity.
And one of the things I saw that was interesting in reviewing the show notes this morning was the idea that you use the response period somehow. I don't know how it was phrased, but instead of just doing a round robin, you actually pay attention to which servers respond quicker and send more requests to them. Am I expressing that right?
Yeah, one of the things that Linkerd does is performance-based routing, right? And so based on whichever instance of a particular service has the fastest performance, you can configure Linkerd to take any incoming request, right, and pick the best one to be able to fulfill that dynamically. Yes, that is one of our very key features.
And there must be other players in this space. Obviously, this is a known problem being solved over and over again by various entities, both commercial and open source, although those are not opposed to each other. I'm just saying, I keep doing that accidentally myself. Both proprietary and open source. There's the proper dichotomy there. What makes Linkerd better or unique?
Yeah, I think there's so one, yes, there are new players in this space, and two, I think it can be somewhat confusing for new users entering the ecosystem. And one of the things that I'm trying to do is address that. Actually, there's not as a plug, but there's an O'Reilly book that's coming out in Q1 that tries to address sort of where different products operate and what some of your considerations are when trying to figure out like where you should dig in. And so let me at least put it to you this way in a high level. Every service mesh should have two different components. There is a data plane, which is that proxying layer that we've been talking a lot about, right? Like where data is actually moving between instances. And then there's a control plane that sits on top. And in that control plane, you can set policy around, like how requests should be routed, right? What your acceptable timeouts are, right? Some sort of security policy. All of that can be set in the control plane. And when you as an operator interact with the service mesh, you should interact with the control plane. The data plane reads from it and alters its behavior accordingly, right? And so I say this to describe what some of the different options are out there. Linkerd has a data plane and a control plane. A lot of times, Google, IBM, Red Hat, and Lyft partnered to release Istio and Envoy. And you can use those components separately. Envoy interacts or acts as the data plane of your service mesh, and you can go ahead and either plug in your own control plane, configure it yourself, or put a control plane like Istio on top of it and couple those together to be a full service mesh solution. Conduit has both a data plane and a control plane. You'll see other players in the space. I know Nginx, for example, being a well-known and well-used software proxy, is interacting at that data plane proxying layer. So there's been a lot of excitement and a lot of new things, but where exactly you should get started and how to navigate your way through those, I think that takes a little bit more of a deep dive into what's happening in each layer and maybe the functionality that you particularly need in your use case.
Cool. Hey, we're almost out of time. Is there anything let me use English here. Is there anything we didn't ask that you wanted to make sure our audience is aware before we have to let you go?
I think you've hit on a lot of the really good talking points. Here's one thing that I would plug is a lot of my background as an infrastructure engineer and as a consultant, previously working at Chef, did a lot of training. I did a lot of conceptual on-ramping. I think it's very, very important to me for the community to understand, what this new tool is, where it fits, how to use it, and to get a lot of direct feedback from folks about what they're learning, what points we need to, shine a light more over to make this a well understood thing. And so if you have feedback on that at all, if there are questions or comments or, there are things you want us to highlight, please reach out to me. I think that's a lot of what I'm doing with community at Buoyant. And so I think this podcast has been very helpful to explore a lot of those topics. And if there's anything that we touched on that the audience hasn't already gotten a taste for, please reach out to me directly, and I'd love to hear your questions.
Cool. Well, that is a wonderful response to that question there. Thank you very much for that. And so I have two final questions that I have to ask, or else my audience actually gets mad at me. So what's your favorite scripting language?
Oh, man. I grew up in a Bash era. The things that I can do in Bash are amazing. I've kind of moved on from those days. And working at Chef, I did a ton of stuff in Ruby, and that sort of became my new go-to. But I'm actually really starting to love Go. So, but if you're asking what's tried and true and what's in my heart, I'm a Bash guy, and I still use Vim. So, that's my background.
Oh, that was your other question. That was going to be what text editor do you spend all day in? That'd be Vim, right? So, yeah. Okay, good. Well, it's been wonderful having you on, George, talking about your projects that Buoyant is putting forth here, and I'm sure you'll get at least a couple new eyeballs on your text here, or earballs, whatever we call those now. Earballs. It doesn't make any sense. They let anybody do this show. George, thanks for being on the show today.
Thanks for having me. This has been great.
All right. Yes. Well, that was George.
It'll all come
George
out in the edit. Don't worry, Randall.
What edit? This thing doesn't go edited. This is live. We're doing it live. Come on. Okay. So, what do you think there, Simon? While I hunt for next week's guests.
It's all very cool stuff. I think it's very exciting to see this particular challenge being solved. When I first saw the idea of microservices, which of course was a retread of ideas that we played with in the 70s and then in the 90s.
Yes.
The first thought that struck me was, well, it's great having all of these servers, these microservices everywhere, and you can scale up by having millions of them, but how the hell is anyone ever going to find the service to use? And so this is a great answer to that question, and it's interesting to see two answers coming up. I'm quite fascinated by that. I'm going to be very interested indeed to see just how open this community turns out to be. It's a very difficult problem space in which to be an individual.
Yes.
You've really got to have a team around you to make anything work here. And for me, looking at the next decade, I don't know if you know that February the 3rd is the 20th anniversary of open source. And so we're just about to go into the third decade of open source. And one of the big challenges of that third decade is more and more open source projects need you to be one of many rather than just one cutting your own furrow. And I think the big question with all these things is what the dynamics are of bringing so many people together. So I'll be looking at these two projects very carefully to see exactly what happens there, whether they end up being captured by the companies that have involved in them early, or whether they end up seeding an industry where software freedom is one of the characteristics. I think that's really my biggest concern around all this. The tech is great, but how do I stay free using it? And so that was really what I was angling for in asking George some of the questions, because there's no doubt that the tech is cool. I'm just a little concerned about my freedom using it.
Yeah, it's always a valid question to have, especially as we're looking at all these different possible solutions in the open source community from various supports and things. I did like George's final point, though, about how Linkerd and Conduit are both like both the data plane and the control plane, whereas that wasn't clear to me before. That's like some of the stuff I saw at the Red Hat Summit. Was it Red Hat Summit? Somewhere Red Hat was involved. Yeah, okay, right. And all things open. There was a lot of talk of containers and people rolling stuff out, especially from the CNCF. And then all of a sudden, I saw these two projects. I didn't know how they related to each other. And then George said, "Oh, well, Linkerd is like both layers of those." Oh, okay, I get it now. I get it. You don't have to make all the fine edges actually fit together, because we've already done all that hard work. So I appreciate that very much, and I think that really clarified it for me. So I know I'm definitely walking away with one important fact today, if not many, but at least one. That's embarrassing. Anyway, and earballs is not a word. Okay, so that's the two facts.
That's your second fact for the day. Yeah, two facts. Two facts. Yep.
Two facts for today. Yes, exactly. So, anything else before we talk about the upcoming guests?
Well, I was also interested to see that Conduit is written in Rust. I've heard a lot from friends at Red Hat about Rust and how valuable it is. And this is the first really complex piece of software that I've seen written in Rust. Maybe there's others, and I'm just uninformed. It's very likely. But I find that also an interesting trend. That it isn't all about computer science languages like Scala, that it's actually happening in languages that, like Rust, which are emerging out of the newer generation of developers. So I found that fascinating too.
Yeah, and Rust is also one of those projects that it's on my short list. I really want to get somebody to talk about that, because I did actually attend a presentation at All Things Open in Raleigh, a 1-hour presentation from a Rust person, and I invited him to come on the show, but I haven't heard back from him yet, so we'll hopefully get that soon. But one of the things I really liked is that they can run lockless threads, because there's no data in place changing. So it's all like I may be explaining this wrong, but at least it's the impression I took away from that, which is that you can actually run high performance threads, because no two objects will need to write in the same space at the same time, so you don't have to lock, which I thought was pretty cool. So anyway, more on that when we actually get the Rust show happening. So we'll just enjoy that when it comes along. Well, let's talk about who's coming up. We do have a number of guests signed up for already. Starting next week, we have Pyrex, which is not the kind of glass; it's PYRX. Virtual screening software for computational drug discovery. I don't understand any of that, so it might be a buzzworthy heavy show, but we'll see. Following that, Open Mainframe project, which will increase collaboration across the mainframe community. Apparently, most of the big supercomputers these days are running Linux, and so having a good set of layers of open source software on top of that is a very, very useful thing. Just added to this schedule between last week and this week is Aragon, which are blockchains for democracy, basically having blockchain support to be able to do very, very important civic projects, things like that. I really look forward to that show as well. Process Maker, which is a workflow manager. Scan Code, which scans code, literally. Anti-text licenses, copyrights, packages, manifests, and dependencies. You can see all those and more on the big spreadsheet for this show, twit.tv/FLOSS. Links to there. That's the homepage for the show. If you have any other suggestions, like today's project came to be this way, you tell the project leader or the community coordinator to email me, merlin@stonehenge.com. My email address is on the homepage for the show, twit.tv/FLOSS is all you have to remember. We do have a live stream. We took a number of questions from there today. It's at 9:30 a.m. Pacific time on Wednesdays at live.twit.tv. Usually, occasionally we have to move it around. You can follow us at Floss Weekly on Google+, and at Floss Weekly on Twitter. You can follow me at Randall L. Schwartz on Google+, and at Merlin on Twitter, MERLYN. That's on Twitter there. I have a message from the home office says to read this every single show so far. What are your favorite segments, shows, or moments on Twit this year? We're putting together our best of episodes and want your help. Head over to twit.tv/bestof. That's BESTOF, all one word. Fill out the form with whatever information you remember and be a part of making these special shows that will air the week between Christmas and New Year's. So that's something from the home office to read. Simon, anything you want to plug today?
Not really. We're coming to the end of the year. I've just been through my busy season touring the US East Coast conferences. But the next thing I've got coming up is Fosdem. Fosdem is the Free and Open Source Developers European meeting. It's an absolutely enormous event for free and open source software developers. It's completely free of charge, happens in Brussels the first weekend in February. If you've never been, and it would be easy for you to get there, I really strongly recommend that you put it on your calendar right now, because every project you've ever heard of and pretty much every project you've never heard of is going to be there. And there's a fine set of keynotes as well, including hopefully one from the Open Source Initiative as we announce our program for next year, which is the 20th anniversary year of open source. It was in February 1998 that the founders of OSI and many others got together and coined the term open source. And we've been through the stage of being called crazy and a cancer on society. And we've been through the stage of being a software exploitation bubble, and we're now into taking over the entire technology world. That's the plan for the next 10 years. So do come along to Fosdem. I'll be talking about that as my keynote there. And then after that, I'm in Barcelona in April. So I would love to meet you if you're going to be there. I'm still writing regularly at meshedinsights.com. Which, if you're watching the video, is there on the screen, at the foot of the screen. And I would love to have you read those articles and give me feedback. And if possible, give me some sponsorship to keep me writing them. That would be cool as well. I think that's everything, Randall.
Cool. And Simon, as always, your insight into how community functions and how various nuances in design of your business model, design of your licensing model, always a welcome input into the show. So I appreciate once again you being able to take time out of your busy schedule to be on here today. So thank you very much, Simon.
It's my great pleasure. And OSI has got pretty busy, and I'm still on the board at the Document Foundation at the moment. And occasionally I get round to doing work for the company. So it's great to be on the show too.
Absolutely, Simon. Well, thank you very much. And as I always say, we'll see you all again next week on FLOSS Weekly.